Dear students, today we are going to discuss Module 5 Industrial Drives and Application Synchronous Motor Drive. Under this module we are going to discuss about torque versus stepping rate or pulsing rate characteristics. So here some of the important things we should know how to use a stepper motor. That is, if you want to use stepper motor or any motor, if you want to use for particular application, we should know the characteristics. Okay, we should know the characteristics of that particular motor. So here that we are going to discuss the proper use of stepper motor by knowing the characteristics and in order to use properly, we are going to discuss the characteristics, that is torque versus stepping rate characteristics. As the step rate is increased, the rotor has less time available to drive the load from one position to the other position. Okay, if you keep on increase the step rate, the rotor will have very less time available, which is having very less time to drive the load from one position to the other position. Beyond a certain pulsing rate, the rotor cannot follow the command and it will start to miss the pulse. Whatever the pulse it is receiving, that will be. So what we are going to do, which range to which range we can increase the stepping rate in order to get proper synchronization between the motor and the load, and in order to avoid missing the pulses, command pulses. Okay, now to operate the motor safely, to operate synchronizingly, we are going to study this characteristics curve. This is the torque versus stepping rate characteristics. And see here, if the values of the load torque and pulsing rate or stepping rate such that uh, the point of operation lies inside this curve, the curve 1. Okay, if it lies inside the curve 1, then the motor can start and also synchronize without missing a pulse. Okay, so if the load torque and the pulsing rate or stepping rate, if the load torque, the pulsing rate and stepping rate are such that the point of operation lies in this portion, that is curve 1 portion, then the motor can start and synchronize without missing the pulse. For example, for the load torque TL1, for the example, the load torque TL1, okay, the load torque TL1, and the motor can start. Okay, for the load torque TL1, the motor can start and synchronize without missing the pulse if the stepping rate is less than S1. Okay, if the stepping rate is less than S1. Okay, for the load torque TL1 and your this one, the motor can start synchronizingly without missing the pulse. Suppose without missing the pulse if the stepping rate is less than S1. Okay, once if the motor has started and it is synchronized, the step, now we can increase the stepping rate. Once if the motor started and synchronized, and your stepping rate can be increased. Now you can increase the stepping rate. Once the synchronization happened, you can increase the stepping rate. That too, this stepping rate can be increased up to S2. Okay, the stepping rate can be increased up to S2. Okay, and here one more thing. However, if the stepping rate is increased beyond S2, if the stepping rate is increased beyond S2, then the motor will log synchronization. So thus this area between the curves 1 and 2 represents for various torque values. The range of stepping rate which the motor can follow without losing the step. Okay, can follow without losing the step. And here this area is called slewing area or slew range. Okay, this area is called slewing area or slew range. Slew range is nothing but it is useful for speed control. Here the slew range is only for useful for speed control and not for position control. Okay, this is the slew range. This is the region where we can control the speed, but position we cannot control. At the stepping rate corresponding to slew range, the motor cannot be started or the motor cannot be reversed, okay, without losing steps. So to attend so, in order to attain the slewing speed, whether from the rest or from the bidirectional mode, the motor must accelerate carefully, and then we can go for the lower pulse rate. Okay, so if you want to accelerate, then you have to use lower pulse rate. Okay, so then only we can reverse the motor. Okay, so during this region, we cannot go for braking or we cannot go for bidirectional. Okay, if you want to go for bidirectional, the motor should be accelerated carefully by varying the low pulse rate. Okay, so this is about your torque versus stepping rate characteristics. Okay, so this is very important question. So this pulse range, sorry, this slew range is only suitable for speed control. It is not suitable for position control. So thank you students. If you are having any doubt, you can post it in the command box. Okay, and next thing, one more thing you should know. Similarly, if you want to stop or reverse the slewing range, similarly if you want to if you stop or reverse the slewing range, motor must be carefully deaccelerated. Okay, if you want, first one I told, if you want to do braking or bidirectional, you have to do acceleration. You have to do the motor first. You have to do the motor acceleration by slowing the pulse rate. At the same time, if you want to stop the motor, if you want to stop the motor or reverse the motor, what you need to do in the slew range, the motor must be carefully deaccelerated. Okay, deaccelerated to some speed within the bidirectional capability. Such acceleration and deacceleration operation without losing any step is also called as ramping. Okay, what is mean by ramping means acceleration, and we have to do the acceleration and deacceleration without losing the steps is known as ramping. So what is meant by slew range? This is the range where we can operate the motor safely for controlling the speed. And or if you want to start the motor or if you want to stop the motor, you have to do within the slew range, means slowly, by slowly we have to accelerate the motor, and for stopping we need to do deaccelerate the motor. Okay, so this acceleration and deacceleration of the motor without losing the step is said to be ramping. Okay, thank you students.